in this week's episode.
Wood, a common material used in architecture even before and up until this date.
With its characteristics that surely is fit for building structures and is available anywhere, this material is probably a go-to in any construction.
Another material is plastic, flexible in any form that can be used in a lot of purpose.
All this stuff and more will be discussed in today's episode.
Stay tuned as we walk through the world of woods and plastics here in Our Chica. I am Julie Ludovice,
Mary Ann Bagalor,
Leyan Costillas,
Ian Jur Macalisang,
Aisa Fagraga.
Your Car Chicas!
Hi Car Chicas! Now, let's talk first about woods. When you hear the word wood, what comes in your mind first? Chairs, okay. Nature, yes, it can be. How about you, Car Chica Julie?
Furnitures?
Alright, thank you Julie, but for me, I must say shelter. Wood has been used as a building material for thousands of years. It is commonly used to build houses, shelters, and tools, but is also extensively used in furniture and decorative objects or home decoration as well. Now, how do we specify woods as a word itself in general terms? Natural wood. One of the greatest benefits of using wood as a construction material is that it is a renewable resource, making it widely accessible and economically feasible. Natural wood means trees such as logs, trunks, branches, limbs, and etc. with no preservatives, paint, or oil, meaning they are not chemically treated. Natural wood has certain properties that make it an attractive building material. First is its natural warmth. To the touch, wood insulates. Wood has a natural resistance to electrical conduction, providing the finished structure with durability and even safety implications for some instances of fire. Unlike steel, which can expand or even collapse in high heat, as the heat increases, wood actually dries out and becomes stronger. Second is workability. Wood is highly machinable. It can be crafted in all sorts of shapes and sizes to fit effectively to any kinds of construction needed. Third, its infinite variety. No two trees or even pieces from the same trees are alike. Fourth, its strength-to-weight ratio for bridge, boats, homes, and furnitures. Fifth is flexibility, with its ability to bend under pressure without breaking. Sixth, fire protection. Without collapsing, it can withstand a fire for a long time because the charring of surfaces protects the structures from fire. Lastly, its color. Again, natural wood makes it an excellent candidate for building materials because of its natural warmth, workability, infinite variety, strength, flexibility, its color, and lastly, it is a good material for protecting structures from fire. Now, how can we classify woods? A. Kaarchika Lian, do you have an idea?
Yes, we classify woods into softwoods and hardwoods.
Yes, absolutely. We classify woods into two categories. First, softwoods, and second, hardwoods. But wait, the terms hardwood and softwood are often misleading because they have no direct correlation with the wood's actual physical hardness or softness, so that a hardwood can actually be softer than a softwood. Softwoods come from the coniferous trees. They have needle-like leaves. Their leaves are shorter. They grow faster than hardwood trees, but they get spoiled faster than hardwood. Examples of these are pine tree and cedar, which were used usually for prime material for structural building components, furniture, and millwork. While hardwoods come from the deciduous trees. Hardwood contrasts with softwood, which comes from conifer trees, which usually are not broad-leaved. Examples of these are walnut and mahogany. Hardwoods are not necessarily harder than softwoods. Some hardwoods, like balsa are softer than most softwoods. Hardwoods are employed in a large range of applications including construction, furniture, flooring, cooking utensils, and etc. Microstructure of wood. Microstructure of wood is the examination of a stump or the transverse section or cross-section of a tree trunk. Shows three parts: the pith, wood, and bark. Pith is normally small and located at the center of the transverse section. Wood is marked by the presence of concentric layers known as growth ring or annual rings. Bark is also employed more popularly to refer to all tissues outside the wood. The important characteristics which determine the properties of woods are color and odor, specific gravity, moisture content, grain, shrinkage and swelling, and strength. Let's go to the effects of woods. First, decaying. Decay was caused by attack of fungi. Second, checks. Checks are the cracks or lengthwise separation across the annual ring of growth caused by irregular shrinkage during drying. It is formed when the circumference shrinks more than the interior section of the log. Third, shakes. Shakes are cracks between and parallel to the annual rings of the growth caused by abnormal growth of the wood. Fourth, knots. Knots are irregular growths in the body of a tree which interrupt the smooth curve of the grains. Fifth, pitch pockets. Pitch pockets are well-defined openings between annual rings containing solid or liquid pitch. Next, wane is the lock of wood on the edge or corner of a piece. Lastly, warping. Warping is any variation with the plane surface of the piece caused by unequal shrinkage of the board. There are several forms of wrap: the crook, bow, cup, and twist, as you seen in the picture or in the PPT. Crook is the distortion of the board in which the edge is convex or concave longitudinal. Second, the bow is the distortion of the board in which the face is convex or concave longitudinal. Cup is the distortion of the board in which the face is convex or concave across the board. Lastly, twist. Twist is a distortion of the board in which one corner is raised. Now, let's proceed to methods of sewing: the plain sewing, quarter sewing, and the reef sewing. The plain sewing method is the most common. It consists of sewing boards off the log in strips parallel to the pith. These boards are then sewn lengthwise again. Second, the quarter sewing method starts by sewing the log into quarters. Lastly, reef sewing. The grain on the top of the board will be linear, while the grain on the ends will be somewhat slanted. Let's go to lumber. Lumber is a wood that is used in construction. Generally, it is available in even numbered widths: 4, 5, 6, 10, and 12 inches. There are 4 available classifications of lumber. First, the strips. Strips are lumber less than 2 inches thick and less than 8 inches wide. Second, the board lumber. Board lumber are the pieces less than 2 inches thick and at least 8 inches wide. Third, dimension lumber. These are the pieces more than 2 inches and less than 5 inches in any dimension. Finally, timbers. Timbers are pieces that are 5 inches or more on the smallest dimension. The basic units of measure are used for lumber. First, board measure. It is the term to indicate that the board foot is the unit of measurement for most lumber items. The formula is T times W times L over 12. It is equal to board feet, where T is the thickness, W is the width, and L is the length in feet. Second is the surface measure. It is the square feet on the surface of a piece of lumber and it is calculated without regard to thickness of the piece. The formula for surface measure is W times L over 12, where the W is the width and L is the length. The third is linear measure. It is the total length in feet of the board regardless of its thickness or width. For example, 2 times 14, 1 foot long is 1 linear foot. By nature, trees contain moisture in their cell layers. This moisture has to be expelled thoroughly to preserve the wood from shrinkage or decay. Removing the moisture content from wood to minimize structural problems when used in construction or to provide less smoke and more uniform combustion when used as a firewood is called seasoning. There are 2 methods of seasoning lumber. First is natural sunlight or air seasoning. Second is the artificial seasoning. Natural or air seasoning is the traditional method of seasoning timber to stack it in air and let the heat of the atmosphere and the natural air movement around the stacked timber remove the moisture. Methods of air seasonings are piling lumber for air drying. The objectives of air drying wood is to remove the water in wood by exposing all surfaces of each piece of wood to circulating air. Next is the drying time, exposing it to sunlight. The next one is the artificial seasoning. The artificial seasoning is a process where lumbers are stuck in a drying kiln and then exposed to steam and hot air. Under the method, lumber undergoes a quick drying process. The artificial methods of seasoning woods are: first, by forced air drying, second, by kiln drying, and lastly, by radio frequency dielectric drying. Kiln drying of lumber is perhaps the most effective and economical method available. Drying rates in a kiln can be carefully controlled and defects losses reduced to a minimum. Good seasoning is the primary consideration for successful preservation of wood. Wood does not decay naturally through age, nor will it decay if it is kept constantly dry or constantly submerged in water.
So, deterioration of lumber. What causes deterioration? First is wood-destroying fungi. Next is wood borers, termites, and weather. There are various factors that contribute to the process of decay of your timber. Here are some culprits when it comes to lumber deterioration. First is the decay. Molds, stains, and decay in wood are caused by fungi. Their growth depends on mild temperatures and dampness. Next is insects. So the common causes of decay in wood are alternate moisture and dryness, fungi or molds, insects and worms, heat, and confined air. Preservation of a lumber. Wood can be treated to prevent or at least delay destruction by fungi, insects, bacteria, marine organisms, and fire. Wood preservatives used to forestall attack by decay, fungi, harmful insects, and marine borers are divided into 2 general groups. So what are the methods of applying wood preservatives? First is the pressure treatment. The wood is placed into an airtight steel cylinder and immersed in a preservative. Increasing pressure drives the chemical into the wood. There are full cell and empty cell processes. The full cell process provides maximum retention of the preservative. The empty cell process obtains deep penetration with a relatively low retention of preservative. The next is non-pressure treatments. This includes superficial applications such as brushing, spraying, pouring, and dipping. Cold soaking, steeping, hot and cold bath, or a thermal process, diffusion, vacuum process, and preservation pads or bandages. Now we go to the Philippine wood. In the Philippines, the wood industry is quite vibrant in Mindanao, especially the Caraga region, which is dubbed the timber corridor of the country. The wood industry requires approximately 2 million cubic meters based on a 3-year average consumption. But to date, the country produces only 1.34 million cubic meter, of which 740,000 cubic meter come from commercial plantations in various regions. So what are the challenges to wood needs of the Philippine furniture industry? Now, how do we access wood products? The Philippines does not produce particle board, MDF, veneers, and we have a very limited selection of wood species. Yet, to be able to import wood products, one needs to apply for an import permit from BOI, BIR, DOF, and etc., which usually takes 2 to 3 months. Next, apply with DENR for a permit to import wood products, which takes about 2 months. Now, here's the sustainability of local wood sources. The main species used is Gemelina and mahogany. These woods come from plantations that are over-regulated. Plantations are not replanting because of red tape and lower than expected profitability. Not viable business equates to not sustainable timber supply. Classification of woods according to size and use. Joists and planks with a height of 2 inches to 4 inches and a width of 4 inches, graded for bending strength, beams, and stringers. Nominal dimension is 5 inches by 8 inches or larger. Rated for bending strength, posts or columns, square with 5 inches minimum dimension, graded primarily for use as columns. Length that varies from 6 foot to 16 inches. Now we go to the wood composites. How is wood composite made? Wood composite is usually made from the same hardwoods and softwoods used for lumber, except using the sawmill scraps and wood waste, and created by mixing groundwood particles with heated thermoplastic resin. So the use of wood composite products, these products are used in a variety of different ways, including both home and industrial construction. Their most widespread use is in outdoor deck flooring, but they are also popular for railings, fencing benches, window and door frames, cladding, and landscape work. Plywood is considered the original composite wood product, manufactured from sheets of cross-laminated veneer which are bonded with moisture-resistant adhesives under heat. Fiberboard is another, made by combining wood fibers with wax and a resin binder under high temperatures and pressure. Particle board is manufactured from wood chips or sawmill shavings pressed with a synthetic resin. Oriented strand board is made from strands of wood arranged in layers and bonded together using moisture-resistant adhesives. Lastly is laminated timber, created using dimensional timber glued together into structural columns or beams, while laminated veneers bond thin wooden veneers into a large belay which can be used for rafters and joints. Now here are the advantages of wood composites. One of the main advantages of wood composite is that because it is man-made, it can be designed for specific qualities or performance requirements. Composite wood is also easy to work with using regular tools and can be efficiently cut, fastened, and drilled using basic skills. One of the main advantages of composite wood is its environmental impact, as it can produce from smaller trees when compared to solid lumber and doesn't require the felling of large, old-growth forests. Composite wood is also less likely to fade or warp over time and far more resistant to rot, decay, and marine borer attack than solid wood. Now here are the disadvantages. Some particle and fiber-based composite woods are also not suitable for outdoor use as they can absorb water and be more prone to humidity-induced warping than solid woods. Another concern regarding wood composites is the adhesives used in their design, with some resin releasing toxic formaldehyde in the finished product, particularly those made with urea formaldehyde bonded products, which is one of the cheapest and most common adhesives. The plastic materials often used in the creation of wood composites also have a higher fire hazard due to their chemical heat content and melting properties.
So, millwork. Now, what is millwork? Millwork is any type of woodwork that is produced in a mill. This includes doors, moldings, trim, flooring, wall paneling, and crown molding. So, molding and flooring are often produced in mill and are therefore considered as a millwork. So, these are the following examples of moldings, which is the common designs of moldings and architectural moldings. So, for example, in the common molding designs, half moon, which is 1/2 by 1, and square moldings, which is 3/4 by 3/4. So, there are many examples, but we'll show you in the illustration. So, quarter round, quarter cove, clover molding, crown, flat molding, which has a size of 1/2 by 1 depending on the unit. And so in the architectural moldings so there are examples such as lining, skirting, center moldings, which has various sizes, cornice, and door jamb.
Plastics are organic materials just like wood, paper, or wool. So what is the role of plastics in architecture?
Here are the reasons why plastics are used for construction application. They can be molded and many components can combine into one. They are durable and corrosion-free. They insulate from heat, cold, or sound. It can be recycled, and most of all, it is lightweight. Plastics are easy to install, take up limited space, require minimal upkeep, and it is one of the most energy-efficient materials over their entire life cycle. For the next part, these are the types of plastics used for construction application. So the first one is acrylic. This one is great for optical clarity, scratch resistance, and rigidity. It is used for light fixtures, LCD screens, windows, and other applications that needs for transparent sheeting. Next one is composite. This one is made of 2 or more constituent materials that improves each other's characteristics when combined. Polycarbonate is used to create sustainable plastic building supplies. This one is a thermoplastic that can be melted down and reused rather than burning it. It requires high level of strength and clarity. This one is used to make safety eyewear, security glazing, and noise barriers. Polypropylene is the most produced plastic in the world. It is used for products that require heat, fatigue, or shatter resistance. The applications includes carpeting, plastic machine parts, piping systems, and electrical cable insulation. Polyvinyl chloride, or also known as PVC. This is widely used for plastic construction materials, not just because it is durable but also it is inexpensive. These are for pipes and fittings, flooring, window and door profiles, and roof membranes. Plastic offers a lot to the construction industry. Here are some of the advantages of plastic building materials. First, it is lightweight, which means it is easy and less expensive to transport. It is rot and corrosion resistant. It is highly weatherable because of how lightly they can be saved. And it is easy to extrude, bend, mold, or 3D print to achieve a wide variety of shapes and sizes. But of course, plastics also have disadvantages. If it is not flame resistant, it is high thermal expansion rate, which means it may not be suitable for high temperature places. If it is too much, it is not good to the environment. Make sure in using plastics that it is recyclable to reduce environmental impact.
Each plastic material has its own peculiar properties to better suit its particular uses. So, here are the following general properties of plastics as a construction material. First, we have appearance. There are many types of models of plastics, such as transparent, colored, and etc. And to achieve this, factories add suitable pigments to the plastic during its manufacturing. Next, we have chemical resistance. Did you know that plastics were made with great resistance against chemicals and solvents? And also, its chemical composition decides how great the resistance is. The third property is dimensional stability. There are actually two types of plastics in terms of dimensional stability. We have thermoplastic, which can be easily reshaped and reused, and thermosetting, who does the opposite. Next, we have ductility of plastics, which in nature is very low. Applying tensile stress to it may break and fail its structure. Next is durability of plastics. Plastics with sufficient surface hardness have a good durability. And for the next one, we have electric insulation. Is what more can a plastic offer than being a good electric insulator, since they are used for linings in electric cables and some electronic tools. Number 7, we have finishing. Any type of finishing treatment can be given to plastics during its manufacturing process, and it is done with uniform when it is mass-produced. Next, we have fire resistance. Did you know that the resistance of plastics to fire and heat varies depending on its structure? Plastics made of cellulose acetate can burn slowly, and those that are made with phenol formaldehyde and urea formaldehyde are usually fireproof. Next is fixing. Fixing plastics is easy. You can just bolt it, drill it, or you can even glue it. After fixing, we have humidity. Plastics that are made with cellulose materials are affected by the presence of moisture, while those that are made with polyvinyl chloride, such as PVC pipes, offers great resistance against it. Next, we have maintenance. Maintaining plastics is simple, since they do not need surface finishing coats or paints. Next property is melting point. Generally, plastics have a very low melting point. Some may melt at just 50 degrees Celsius. However, thermosetting plastics have higher melting point than thermoplastics. After that, we have optical property. There are many types of plastics, such as transparent that allows light in its original direction, and semi-transparent that changes light rays direction. Next, we have recycling. Disposal of plastics causes severe pollution to the environment. So instead of burning and throwing it away, we can just recycle it. And now, we have sound absorption. Plastics such as acoustic boards are made by the saturation of phenolic resins. These are used in theaters and studios, as it provides great sound insulation. Next is strength. Plastics are strong material, but using it as a structural component is still impossible for now. Generally, reinforcing fibrous material into plastics may improve its strength. Still, we cannot assume that it is on par with metals. For the next one, we have thermal property. Thermal conductivity of plastics is very low, which is similar to wood, but foamed and expanded plastics can be used as thermal insulators. Next, we have weather resistance. Most plastics are capable of resistance against weathering, but the major problem is when it is exposed to UV rays and gets brittle. So to prevent this, plastics are incorporated in filler and pigments that helps absorbs and reflects the UV rays on its surface. And the last one, we have weight. Did you know that plastics have low specific gravity that ranges from 1.3 to 1.4? That is why they are light in weight and easily transportable. And those are the general properties of plastics as a construction material, mga ka-archikas. I hope you learned something new.
Hi guys, I just finished watching our video and have you learned something from it? Well, for me, I was amazed how softwood and hardwoods are not about the texture at all, when all along I thought that it was.
Yes, you're right, Julie. They have no direct correlation with its actual physical hardness or softness. Actually, softwoods came from coniferous trees, while hardwoods came from deciduous trees. Leanne, on the common molding designs, which type is used commonly in your house?
Oh, hi, Marianne. Well, that's an interesting question to ask. Well, to tell you, wood is both an amazing and frustrating material when it comes to creating designs. But your question is, it depends on the person's preference on what designs he or she is gonna choose. But I'm gonna tell you some common molding designs used in households, and these are half moon, crown, and flat moldings. I guess these three designs are commonly used. So yeah, that's basically it. And how about you, Izel? What more interesting topic can you add on about plastics?
Oh, yes, Kyla, I learned that plastics are not just a contributor to pollution if we use it in the proper way, and of course, in moderation, everything will be fine. How about you, Ian? What have you discovered in studying this topic?
Thank you, Aisel. So I learned that plastics is actually a complicated thing, and that each of its properties contributes to its effectiveness as a construction material. That's it.
Oh, wow, that's really informative. Agree, Julie?
Yes, and I guess we all learned something from what we have discussed. So, this is the end of our discussion. I'm Julie Widibise.
Mary Ann Bagalor.
Dayan Costillas.
Aisel Puletyu Fagaragan.
I am Ian Jer Macalista.
See you on Makar, chicas!